Welcome to the latest episode of the Catalyst Health and Wellness Coaching Podcast. I'm your host, Dr. Bradford Cooper, and today we're going to be discussing the age-old question, why do we overeat? Our guest is Dr. Stephan Guyenet. Dr. Guyenet has a bachelor's degree in biochemistry and a PhD in neuroscience, and then he completed a postdoctoral fellowship on the neuroscience of obesity and eating behavior. So he knows his stuff, folks. His research publications in scientific journals have been cited more than 2,100 times, and he is the author of the 2017 book, The Hungry Brain. It was named one of the best books of the year by Publishers Weekly and called essential by none other than the New York Times Book Review. With all the discussions around food choices and overeating in the world of health and wellness that we live in, we were very excited to have him join us and share his insights. By the time you're hearing this, the November Fast Track Certification Training Program is probably full. But for those of you looking to pursue your national board exam through the MBHWC before they increase the requirements, we do have one coming up in February. It's in Colorado. It's the weekend that follows the Super Bowl, February 8th and 9th, and you can start the on-demand portions of the training as soon as you register. So for those of you who like to work ahead, you can do that at any point. You can find all the details and registration at catalystcoachinginstitute.com. As always, feel free to reach out to us with any questions you have. Anything related to the National Board Certification, coaching, how it fits into your career, whatever it might be, results at catalystcoachinginstitute.com. Thanks for joining us. Now let's jump into the conversation with Dr. Stephan Guyenet on this episode of the Catalyst Health and Wellness Coaching Podcast. Well, Dr. Guyenet, very good to have you here.
Thanks for having me, Brad.
Absolutely. Well, the audience knows your background. They know your education, very extensive education. They know about your book. How did you come to study the neuroscience of behavior and obesity? That's a pretty dialed in and incredibly timely topic to have on your radar screen for as long as it has been.
Yeah, it was kind of a convergence of different interests for me. So I've been into science since a very young age, and I pretty much always knew that I would do something related to science. And I was particularly interested in neuroscience because the brain is one of the main remaining frontiers in science. It's one of the things that we have yet to learn much about. I've also been interested in health and fitness from a pretty young age, and ended up going to college and studying biochemistry with the idea that I would apply that to neuroscience. And then in graduate school, I did a PhD in neuroscience, and I was studying a neurodegenerative disease that's pretty rare, and decided I wanted to work on something that was more impactful. And at that time I was learning a lot more about nutrition and body fatness and fitness. And I was seeing that, hey, this has to do with the brain. And guess what? I have a PhD in neuroscience. So I decided to merge my interest in fitness and body fatness with my interest in neuroscience. And I did a postdoc in neuroscience of obesity with Mike Schwartz at the University of Washington, who's really one of the fathers of leptin research, leptin being the most important hormone in body fat regulation. And so it pretty quickly dawned on me that if we were going to understand obesity, we were studying the right organ, that is to say, the brain. And this is really, if you sit back and think about it, it should be pretty obvious to anyone. The brain generates all of our behaviors, right? Whether that's eating behavior, how much you eat, what you eat, how we move our bodies. And it also regulates a lot of our physiology, including how much fat we have in our body, what our hunger level is, what's going on in our digestive tract, what's going on in the pancreas, et cetera, et cetera. And so, I mean, it's a pretty obvious frame to take when you're thinking about obesity, why some people have it, why some people don't, how food environment and foods impact it. It's a pretty obvious frame to take, but it was a frame that I wasn't seeing people take commonly in the public sphere. And so, and of course, in the research community, people had been taking that frame for a long time, and there was lots of research on it, lots of review papers on it. But that information that was so profoundly informative was not really trickling down to the general public. There was really an information vacuum, I perceived, and that was allowing all kinds of harebrained theories to proliferate. So I decided that I wanted to be the guy to communicate this to the public, and that led to the publication of my book, The Hungry Brain, which is really the first that I'm aware of, the first general audience book that steps back and focuses somewhat comprehensively on the role of the brain in eating behavior and body fatness.
I love it. I love it. Can you broaden us out a little bit here and give us that 10,000-foot view of your research, kind of set the context for our conversation today for those people listening?
Basically, the big picture is that, we evolved via natural selection to perform well in certain types of environments that our ancestors lived in. And for most of human existence, we were hunter-gatherers trying to, extract calories out of a difficult landscape. Then after that, for, depending on your ancestry, anywhere between 100 and 10,000 years, we've been more agricultural based. And so, but still living as predominantly subsistence, in a subsistence manner, meaning that we are the primary producers of everything we eat. So everything that crosses your lips for almost all of human existence is something that you either hunted, gathered, or grew yourself. And so obviously that is radically different than the way we live today, almost all of us in affluent industrialized nations. And so basically what's happened is that we have what's called an evolutionary mismatch, where the way that our brain circuits were designed to interact with our food and our food environment in terms of the types of foods that are available, the ease with which we can obtain those foods, and that sort of thing is profoundly mismatched with the way our brains are designed. So our brains are calibrated for a world in which it's not so easy to get food. And yet we live in a world where it's incredibly easy to get food. And, we like to complain about the cost of food, but the truth is that it's never been cheaper in all of human history. If you factor in effort and time cost, food is way cheaper in the modern United States than it's ever been in human history. It's about 10% of our disposable income currently in the US, and that includes a lot of eating out. So basically, these brain systems that we evolved to cause us to eat the right amount of food and the right type of food in an ancestral environment are essentially misfiring in the modern environment. And a lot of these circuits, this is really the premise of my book, is that a lot of these circuits are non-conscious. So these are things that are hardwired into your brain to generate, they're hardwired into your brain, and they evolve to generate specific motivational states in specific scenarios that drive you to specific eating outcomes. And so, for example, hunger. Hunger is not something that you choose to experience. You don't say, oh, hey, it's 6:00. I feel like being hungry, so I'm going to be hungry right now. No, it's something that arises from non-conscious brain regions, and you experience it as a result of that. Cravings are the same way. You don't decide whether or not you're going to have a craving. A craving arises from non-conscious brain regions, and then you experience it. And so, and there are other things like this. There's satiety, there's hunger, there's cravings, there is the circuits that non-consciously regulate your body fatness, that affect your metabolism and set the gain on your appetite and other things like that. These are all hardwired systems in the brain that we actually know a fair amount about how they work in terms of how the neurons are hooked up and what chemicals they're using to communicate, what hormones and nerve signals they're responding to. And all of this stuff, these systems just basically push us to overeat in the modern food environment because they're receiving the wrong signals today.
So you talk about a quote I pulled from a previous interview you were involved with. You talk about the main driver of overconsumption isn't pleasure, but motivation. Can you take us on a deeper dive of what you mean by that?
Oh, yeah, we're getting into it now. Yeah, absolutely. So we often talk about food palatability or how delicious the food is. That's something a lot of people talk about as a factor that impacts food intake. I talk about that as a factor that impacts food intake. But the truth is that that's kind of a oversimplification of how the process works. So on a neurobiological level, pleasure and motivation are two things that usually travel together, but are not the same thing and do not always travel together. So for example, there's research, I think Kent Berridge is one of the people, maybe the main person who advanced this idea. In rodents, there are certain brain pathways that stimulate motivation that will get those rodents to eat a ton of food. So you stimulate those pathways and put food in front of them and they'll eat a bunch of food. But if you measure, there are certain measures you can use that indicate how much they like the eating that they're doing, what's the pleasure response to that food, and it's unchanged. So what it appears like is that they are overeating due to a heightened motivational state, but not experiencing heightened pleasure in response to that overeating. And this is something we see in the context of like gambling addiction and drug addiction. I mean, I don't know if you've ever been to a casino, but if you walk through a casino at like really early in the morning, like let's say 3 or 4 a.m., there are people sitting in front of slot machines by themselves pulling the lever. You know what I mean? And they're often like kind of rough looking. Do you think those people are enjoying playing the slot machine at that moment at 4 a.m., like spending their social security check or whatever it is? I mean, I seriously doubt they're enjoying themselves. But they are motivated to continue doing that basically they have a runaway motivational state that we would often refer to as addiction,
right?
In response to that stimulus. So there are situations where motivation and pleasure can be separable. And really when we're talking about, because they can be separable, I think when we're talking about food intake, what we really care about is motivation, because motivation is what gets you to actually engage in the behavior. Pleasure is just a state you experience as you're engaging in the behavior or after the behavior. So, pleasure is not what gets you to eat the ice cream. Pleasure is a state that you experience as you're eating the ice cream. So it's not the difference between eating it and not eating it. It's not the difference between eating a lot of it and not eating a lot of it. The difference for that is motivation. And so in real life, most of the time, motivation and pleasure co-occur. So if you have a craving to eat ice cream and you fulfill that craving by eating ice cream, you will experience pleasure as you eat the ice cream. So those are neurobiological processes that in real life, most of the time are actually pretty well linked to one another. So this is why I don't generally spend a lot of time trying to suss this out, because I think it confuses people and doesn't necessarily lead to a lot of practical value. Yeah. So sometimes I will just say palatability, but what I really care about is more like motivation. And another word that I use that I think conveys that better is seductiveness. So rather than talking about food palatability, we can talk about food seductiveness, because that's not just about how much you enjoy it. That's about how much it calls to you, how much of a craving it stimulates, how much of a motivational state it generates that causes you to engage in that eating behavior. So I like that word seductiveness because it paints
a good picture.
Yeah, and it's an intuitively easy word to understand. Like you hear that and you're like, oh yeah, I know what you're talking about, as opposed to using, the technical term reward or food reward, and people just aren't quite sure what I'm talking about.
Okay, so on a practical level, you've taken us on a deep dive. Now, if we pop back out to the surface and say, and this means X for those of us trying to control what we're eating, and we'll dig into this a little bit more, but can you give us a few hints along those lines of, okay, so what? We have a difference between motivation and pleasure. Now what?
Yeah, so I think the thing to focus on is food seductiveness. And I want to take a little step back and I want to talk about what the brain finds seductive.
Okay.
So, what is it about food that the brain wants that makes the brain cause cravings, cause liking, drive you toward that eating behavior that's often hard to control? So, essentially, our brains are hardwired to respond to specific physical and chemical properties in food with the release of a chemical called dopamine in the brain.
Okay.
And dopamine is a key chemical that mediates motivation and learning about how to be motivated by different things. And so the substances in food that stimulate dopamine release that are either known or strongly suspected to do so are carbohydrate, so including starch and sugar, fat, protein, glutamate, which is an amino acid. So it's kind of like protein, but it's a little bit different. That's the meaty umami flavor that is in soy sauce and MSG and bone broth and cooked meats. And then salt, sodium chloride. So those are all things humans are hardwired to want. They're things that every culture enjoys eating. If you go to Sichuan province in China, people are going to like salt and fat. If you go to Paris, people are going to like salt and fat. But there are many other preferences that those two cultures may not share. People in Sichuan may be disgusted by strong French cheeses, and people in France may not enjoy, the flavor profile or the texture of Sichuan cooking. But those really basic elements that cause dopamine to be released in the brain are things that all humans enjoy and prefer and are motivated by. So basically, the higher the concentration of those things up to a point that we call the bliss point will cause more and more dopamine release in the brain. And the way to get maximum dopamine release is to combine those things together. So if you think about chocolate, for example, chocolate is fat and sugar together in a really concentrated form, right? And then you can add salt. Now you have Reese's peanut butter cups. A lot of people really like that. So essentially, calorie-dense combinations of these things stimulate a lot of dopamine in the human brain. And of course, these substances that I just mentioned that cause dopamine release, all of them except salt, are delivering calories to the body. Sure. And so basically, the brain is calibrated to be motivated to seek calories in food. And that's not surprising because, as Herman Ponzer said, Herman Ponzer is an anthropologist who I interviewed for my book. He said, life is a game of turning energy into kids. So from an evolutionary standpoint, it's all about obtaining energy and then using it to increase your reproductive success. And so basically the brain is very focused on obtaining calories from the environment. That's how our motivation is wired.
So how do we overcome that, though? Is it because as you're talking, I'm thinking, and I'm sure everybody has their different preferences, including you, but I'm thinking, well, that's not so appealing to me, but that is. And is it because I have a different motivation that overrules my desire for that thing?
Well, humans are very complex, and there are a lot of different things that go into our motivations and our eating behaviors.
Sure.
However, if you look on an average population level, you can see that people do gravitate toward calorie-dense combinations of these ingredients. So, if you look at the top sources of calories in the US diet, the top 10 is all like pizza and cakes and cookies.
I think you tweeted that out the other day. I thought that was a cool list. Yeah.
Yeah. So, and it's in my book as well. So and if you look at the foods that people crave the most, it's the same thing. They're all calorie dense combinations of these things. When you look at foods that are lower calorie density and are predominantly just one of those things, like brown rice or salmon with, plain salmon or lentils or things like that, they're not things that people lose control over. They're not things that people have strong cravings for. They don't stimulate as much dopamine in the brain. And so, there's not I don't think there's really a cure. There's nothing that's going to make you stop liking ice cream. I don't think there's anything that's going to make me stop liking ice cream. And that's a problem because ice cream is available and that's not going
Everywhere.
to change either.
Right.
But I think that if we design a diet that has properties that don't stimulate those brain regions as much, those dopamine releasing and dopamine conditioned brain regions, if we surround ourselves, or I should say, if we have a food environment that presents foods to us that don't cause dopamine to spike as much, it's going to be much easier for us to control our eating behavior. We'll end up eating fewer calories without experiencing more hunger, and also controlling your food environment, because if you have foods around you all the time, that's going to get your dopamine spiking as well. And so really to control that seductiveness that we often struggle with, you want to first reduce the problem foods that you're eating that are calorie dense combinations of those substances I mentioned. And you know, this boils down a lot to common sense. I want to be really clear about that. Like, basically the things we think about that stimulate dopamine release a lot are junk foods. They're the things we know we shouldn't be eating a lot, like pizza and ice cream and candy bars and whatever. But also some things we don't necessarily think about as much, like bread and crackers and cheese and that sort of thing. But the food environment is huge too, because it's those visual cues or the smell cues when you see those foods that previously you've eaten and previously caused lots of dopamine release. When you see those foods, your brain's like, oh, I remember that. And then the dopamine gets spiking even before you start eating it. And that will cause you to want to eat it. And that can be hard to control. And that's called a craving, of course.
So is that the main take-home message for folks of, and like you said, it's common sense, but is that the main item that we can take away is you've got to be so aware of your situation, and that fits your seductiveness wording, because when you think about your potential for an affair or getting drawn into other things that are unhealthy for you and potentially ruinous for you, you're careful about what situations you put yourself in. You don't walk yourself out to the edge of the bridge and hope you don't fall off. Are you saying that's the primary takeaway in terms of this one aspect, is don't make it readily available? It's okay to have occasionally, but when it's sitting there in your cupboard 4 feet away, it's not a great decision.
Yeah, absolutely. And I don't want to give people the impression that this is the only piece of practical advice that I have, but when we're talking about the seductiveness piece of this puzzle, yes, it's
That's
all
a biggie.
about control your food environment, don't expose yourself to those cues that get your dopamine spiking, and in the food that you actually eat and that you have in your house, have it be lower in calorie density and lower in these foods, and have fewer of these foods that combine multiple dopamine stimulating ingredients together.
Okay.
That will help you control your motivation and your calorie intake and your waistline.
Okay. And then you just mentioned something slightly different. You said control the cues. Now that's a slightly different train of thought. Is there something in there that you'd like to develop out a little bit more in terms of, it's not just have them available or don't have them available, but it's be aware of how you cue yourself? Is that TV ads? Is that what
Yes,
is that?
yeah, advertising is part of it. So let me explain a little bit more about how dopamine works to explain how this works. So essentially what happens, let's say you eat pizza, you get lots of dopamine going in your brain because your brain says this has lots of things in it that I like. And what your brain does when it gets that, dopamine tsunami is it remembers all of the sensory cues that you were experiencing as you were eating that pizza. So the taste of the pizza and the smell of the pizza and the appearance, the little round pepperonis and the triangular slices and the greasy box and the place where you ate it and the people you were with and the situation, all of that stuff gets stamped into your brain as a motivational trigger the next time you experience those cues. So the next time you experience those cues, let's say you walk in or you walk past the pizza place, or it's somebody's birthday and you're accustomed at work to having pizza on birthdays, or you smell the smell of the pizza or you see the box. suddenly your dopamine gets spiking again and you have a craving. You're experiencing that motivational state that then you're going to have to grapple with, and there's a good chance that you will lose that battle. So essentially, it's those cues that get your dopamine spiking and get your cravings going as a result of previous instances of dopamine mediated reinforcement. And so it's just like if you're trying to quit smoking, it's the exact same thing, because smoking gets you addicted by stimulating dopamine systems in your brain. So it's the same thing. If you're trying to quit smoking cigarettes, you don't go to the bar where you used to smoke. You don't walk into the place where you used to buy cigarettes. You don't leave packs hanging around your house. You don't hang out with the same friends for a little while. Those things are all motivational triggers that before you know it, you'll have a cigarette in your hand again. So I'm not saying that food is as bad as cigarettes, but the analogy is there.
Sure.
And the mechanism in the brain is very similar and it can either derail you or you can exploit it to your own benefit. Either way you want to have it. Let me give you a simpler example. Okay. I just to make sure that everyone's on board with what I'm talking about on a practical level. So the difference would be between having a bag of chips on the counter where you can see it several times a day and not having that bag of chips there. Let's say having it in the closet. So every time you walk by that bag of chips and your eyes land on it, there is a chance
There's that seduction.
That visual cue is going to create a craving in you, a motivational state, and you'll eat some chips. If it's in the closet, you may still eat it sometimes, but you're not going to have that regular visual cue triggering your dopamine and making you more likely to eat it than you otherwise would. And so that's the main thing I'm talking about, is getting rid of the food cues specifically. And those can occur due to our own food environment at home, at work, just because we haven't optimized the foods in our surroundings. Or I should say we haven't optimized the availability of foods in our surroundings. And that can also occur through food advertising. So the average American adult sees about 20 food ads a day on television alone. And so we're being bombarded by food cues. Obviously, they're not spending billions of dollars, tens of billions of dollars a year on advertising. They're not peeing that money away, right? Yeah. I mean, they're doing that because it gets you to buy and consume their food. So that's another way that those cues can lead to consumption of unhealthy foods.
Okay. Let's jump into your book. So what were the book is titled The Hungry Brain. It was released in 2017. It got great reviews. What were some of the surprises as you were researching, preparing, writing, putting it all together, talking to different folks? What were some of the surprises that people, if they heard it, would go, wait, what? Or maybe you said that.
I think there are a couple of things. So I don't think there was anything that really shocked me as I was writing the book, because I wrote that book on the basis of a lot of work that I had already done.
Mm-hmm.
And so I had the backbone of it in my head before I wrote it.
How about for the readers though? Was there feedback from your readers where they said, oh my gosh, really?
Yeah, absolutely. So one thing is that most people have a dramatically incorrect understanding of the relationship between calorie intake, calorie expenditure, and body weight. So, and this is an incorrect understanding that even a lot of researchers have. Even some researchers in the obesity sphere will make incorrect statements about how this works. But basically, you hear this all the time. I'm sure you've heard this, that like if you eat one fewer slice of toast every day, you'll lose, I forget what the exact amount is, but a couple pounds of fat a month. And, in a year, you'll be 24 pounds down, and it just keeps going down and down and down. So the implication here is, it's a
straight line.
Why? Yeah, it's a straight line. Why would anyone be obese if all you have to do is eat one fewer slice of toast every day? Come on, it's so easy. Well, that's not actually how it works, for a couple of different reasons. And the first reason is that as you lose weight, you require fewer calories to maintain your body mass. So basically you lose weight, you're losing tissue, right? And that tissue is metabolically active.
Mm-hmm.
And so, that calorie deficit that you establish by eating one fewer pieces of toast a day, it goes away over time as your body gets smaller.
Right.
And so basically what happens is you get your maximum amount of weight loss right at first, and then that slows down and slows down and slows down until you eventually plateau. And so the rule of thumb is for every 10 calories, roughly speaking, for every 10 calories that you decrease your intake, you will eventually plateau 1 pound lighter. And that's just to give credit where credit is due. That's based on Kevin Hall's research. And this is all evidence-based, empirically validated models. So this is not just, different people saying different things. This is what the actual data say. And so a slice of bread is, let's say, 100 calories. So you would eventually lose 10 pounds over the course of about 3 years if you eliminated one slice of bread. So the idea that you would lose 20 pounds a year or something and keep losing is just so wrong. But that's an idea that a lot of people have because they hear it from books and they hear it even sometimes from research papers. They hear it on podcasts. It's not how it works. The other thing that causes weight loss to not be as large as expected is that you actually get resistance from circuits in the brain that regulate your body fatness. And this is some of the research that I did, my research is related to this topic, I should say, of brain regulation of body fatness. And so there's what's called a negative feedback loop. And this is a simple engineering term. It's like a thermostat, for example. So a thermostat contains a thermometer that measures the temperature in your house. And let's say you have your thermostat set to 70 degrees Fahrenheit, and then the temperature drops to 69. The thermometer detects that and turns on the heat to bring it back up to 70. If it goes up to 71, your thermometer inside your thermostat detects that and kicks on the AC to bring it back to 70. So that's called a negative feedback system, and it's a system that is designed to maintain stability of a parameter, in this case, temperature. So we have a lot of negative feedback loops in biology, including in the human body, and one of the things that is regulated in a manner like this is body fatness. So, and particularly in the negative direction. So the brain opposes weight loss pretty vigorously. And so if you begin to lose weight, the more weight you lose, the more your brain will start to fight it. And the way it does that, so essentially your brain detects a decline in the hormone leptin, which reflects declining body fat stores. And then your brain initiates a collection of different responses designed to restore that fat. So your hunger goes up, your cravings go up. Suddenly you're more reactive to food cues. You're noticing foods, especially more calorie dense foods in your environment. And your metabolic rate starts to go down. So you're actually burning less calories going about your day-to-day life than you otherwise would. And so that is one of the main things, and possibly even the main thing, that opposes weight loss and causes weight regain. And I think if we didn't have that fights against weight loss, I think if that system didn't exist, there would be a lot fewer people with obesity than there are, because it would be a lot easier to lose weight than it is. And it would be much easier to maintain weight loss than it is.
But it's only generally, only is too strong of a word, but it's generally only in that direction. It doesn't work the other way.
It does work the other way. It's just that it seems that it's not quite as powerful and it's not quite as consistent between individuals. So we do know that if you're habitually overeating calories, like there are a number of these so-called overfeeding studies in the obesity research world, and they're really interesting studies. So basically they get people to eat more calories by one means or another. Either they're paying them or they're prisoners and they're saying, maybe we'll give you parole. and they find a way to get people to eat more calories, and then they see what happens. And basically, if you're habitually eating a ton of calories, your appetite drops. So as soon as you stop overfeeding people, they typically, what's observed is they will undereat for a period after that. So basically the body is saying, no, we're trying to restore balance here. It's doing that negative feedback thing. Appetite goes down, and that mediates some of the return back to baseline. However, what you see is that this differs between people. Some people are better at not gaining fat than others, and some people are better at losing it after they overeat than others. And what you see in some studies is that people don't settle back down to their initial weight all the way. So they'll lose most of the excess fat they gained when they were overeating. But if you look at them 6 months later, they may have lost 2/3 of that fat, but a third of it stuck around and doesn't look like it's going anywhere. So not only did they not prevent the fat gain that well, but it actually, that overeating, at least in some cases, seems to result in an upward resetting of the level of body fatness that the brain defends against losses. So at that point, maybe when they started, they were 170. And if they tried to lose weight from that point, their brain would fight it. And now they're 180. And if they tried to lose weight from that point, their brain would fight that. And gotcha. So it's an upward resetting of the so-called body fat set point.
Right. Okay. All right. So it's been, 2.5, 3 years since you wrote your book. If you were to add a chapter today, what would you cover?
Yeah, that's a good question. I've been thinking about this lately. I don't think that there is another chapter I would add, but I think there are a couple of extra things I would discuss or update. And one of them that's kind of interesting, I'm still not quite sure what to make of it, but there is some research suggesting that there may be another biological system that regulates body weight aside from that leptin system that I was talking about. So that system that I was talking about, the leptin system, that specifically regulates body fatness. That is a system that specifically measures and regulates body fatness. But there may be another one that actually regulates weight per se, like body mass. And that's called a gravitostat. And there's some research suggesting, essentially, if you take some kind of rodent and you put weighted pellets in their abdominal cavity, you basically make them bigger.
Okay.
Or sorry, you make them heavier without making them much bigger.
Right.
They actually will lose fat mass. They'll eat less and they'll lose fat mass. And that seems to be related to the some signals that are released by bone cells. So the idea is that basically your bone tissue senses the increased load and releases signals that say, hey, we just gained weight, let's eat a little bit less and carry less weight in response. So basically let's lose that excess weight that we just gained.
Well, that's really interesting. So has it been done with humans where we put, I've got a weight vest downstairs I'll use sometimes with jump rope. Has there been any human studies with that where we say, hey, let's throw a 15-pound weight vest on you. Let's wear it for a month and see what happens?
So as far as I know, it has not been done in humans.
Really?
In any kind of scientific way. So yeah, so this research is fairly recent. I don't know if they're going to try it in humans, but I mean, why not? It seems feasible.
Yeah,
like you
makes
said,
sense.
You can put weight vests on people. I will say that in James Krieger's newsletter, he did have a case study where he discussed one individual who was a bodybuilder, if I recall, who used a weighted vest successfully to control his appetite and body fatness during a cut. And so, and this is N equals 1, it's an anecdote.
Right. Sure.
I don't want to put too much weight on it, but I mean, if there are folks out there who just want to experiment with it, I think it's very unlikely to do harm. But yeah, basically what this individual found was that if he continually added weight to the vest and wore it all day such that his skeletal loading wasn't changing. So for every pound he lost on his
Throw another one
body,
on.
he added a pound onto the
Right.
vest. And if he did that, essentially he found that it was easier for him to maintain a lower calorie intake and a lower level of body fatness going into competition. That was his subjective experience.
Some researcher listening to this is going to dial this one up, my friend. That one makes so much sense. So much sense. Okay, so what are some of the key elements being missed out there in the behavior change world? That's the world we live in. There are millions of dollars being spent on obesity, eating habits, the whole thing. And yet, as you mentioned earlier, population outcomes continue to go in the wrong direction. What are we missing?
Behavior change is really the missing piece of the puzzle right now. So
sure.
I think that we have enough information right now on what good diets are and how much we should be eating, how much we should be weighing, etc. We have enough information right now to prevent most obesity, almost all diabetes, most cardiovascular disease. But the problem is implementation. Because it's really hard to get people, especially on a population level, to stick with these interventions for the long run. We know that if they do, we have long-term, big, good randomized controlled trials showing that you basically can practically prevent type 2 diabetes and even reverse it with pretty simple changes. But on a population level, what we need is strategies that help people stick to that. And I think that at this point is where more value is going to come from than squabbling over, incremental gains and understanding which diet is better than which other diet. But, the former question is much harder to answer than the latter. So there's a lot of more research on the latter. All right, so let me see if I can throw out a couple of ideas. Again, I don't want to portray myself as an expert in this area, but I think that understanding how dopamine works and how motivation works in the brain gives some insight into how to manipulate it, and understanding analogies like smoking cessation that I talked about earlier. So basically controlling the situations, the cues that cause dopamine to be released in the brain. So you control the type of food that's around you, you control your exposure to those cues. And then a third element that I didn't mention is you create small effort barriers to consumption of foods, particularly between meals. So, if you walk into the kitchen, you don't want to have anything that you can just grab and throw into your mouth. However, you could have some nuts in shell or peanuts, unsalted peanuts in shell. You could have oranges in their peels. So if you're hungry, if you actually really need energy, you can peel an orange and you can eat that orange and, be full. But you're not going to do that unless you're genuinely hungry, unless you really genuinely want that. So that's really, for me, 3 key things. Don't have the food be too seductive. Don't present constant food cues to yourself, and create small effort barriers to eating, particularly between meals.
I like it. I think that suggestion about the nuts they have not been shelled, they still have the shells on them, is a great tip. It just adds that extra step. All right. So if you're trying to help somebody that you cared about, you're like you said, behavior change is not your thing. It's not your area of expertise. But if you had a close friend, you cared a lot about them, they were already intrinsically motivated. So this is not you telling someone what to do. This is not you coming alongside and saying, buddy, you really ought to. This is someone who's intrinsically motivated. They want to lose weight. How would you approach that with them?
Well, the first step for me is, number 1, control your food environment. So that's the stuff we've already been talking about. And number 2, eat a lower calorie density, whole food based diet. That's really the 2 core elements that I would start with for someone. And there are other things you can layer on top of that if that's not enough. But, and let me just clarify what I mean by a lower calorie density whole food diet. So calorie density refers to the number of calories per gram of a food or per volume of a food. And so things that have more water and more fiber have a lower calorie density. So think about the difference between a bowl of oatmeal, which has a lot of water and a lot of fiber, and white flour crackers, which have very little water and very little fiber. So the same number of calories is going to be a much greater volume of the oatmeal. So that, this relates to another aspect that we didn't talk about, but this is how satiety or fullness mechanisms work in the brain. And I won't get into the details on that for right now. Essentially, that calorie density is one of the things that helps your brain feel fullness. So lower calorie density per unit calorie, you will feel more full. So basically, it causes you to naturally terminate your meals earlier in terms of your calorie intake, yet still feel satisfied with what you ate. And so lower calorie density and whole foods, which goes hand in hand with that. And the main things I think people should be watching out for are refined carbohydrate, like sugars and flours particularly, and isolated fats. So butter, lard, olive oil, even, those are the most calorie dense things in our diet. I'm not anti-carbohydrate, I'm not anti-fat, but I think if you're on a whole food based diet, it's better to get your fat from things like avocados and nuts and meat and dairy. Better to get your carbohydrate from things like whole fresh fruits and potatoes and whole grains like oatmeal. And if you do that instead of getting, your fats and carbohydrates from donuts and pizza and, even sometimes other things that people kind of think are healthy, like chocolate, I think you're going to be better off from a weight management perspective. And that would be where I would start with anyone. And then if people need additional layers on top of that, I might add other things like macronutrient restriction, restricting either carbohydrate or fat. And another thing that I generally recommend that people start with is a higher protein diet. So that would also be part of the starting package.
Okay. Very good. Very good. Any final words of wisdom? I appreciate your time, but anything that I haven't teed up with the right question that you'd like to throw out there to the audience?
I think physical activity is another factor. There's been a lot written lately about how physical activity doesn't cause weight loss or doesn't cause major weight loss, but I think a lot of those studies are based on pretty wimpy protocols and people not adhering very well to those protocols.
Right.
And it is nevertheless true that people, if you create a 500 calorie per day calorie deficit with exercise, people don't lose as much weight as you would predict based on a simple model where they never compensate by eating more. But that's not how real life works, of course. People do eat more. I should say, on average, people do eat more when they exercise. But generally, that doesn't totally wipe out the gains for most people. So for most people, there will be a loss of fat. And there's some evidence suggesting that it's more important for maintenance in particular. So people who lose weight, after they lose weight, it helps them to maintain that loss. One other thing I'll mention, actually, there was a trial that just came out today that was really interesting that I tweeted about. I think folks will be interested to hear this. It compared rapid fat loss to slow fat loss. So basically a short-term, really strict calorie restriction to a longer-term, more moderate restriction, and then compare the results after a year. And basically, from a fat loss perspective, the fast fat loss, which also I should say used a meal replacement system, just destroyed the slow fat loss. I mean, it was like more than twice the amount of fat loss at 12 months. So I think that's part of a broader evidence base suggesting that slower really is not better. We've kind of been told that slower is better for a long time.
Yeah, always.
And I'm not aware that that was ever based on any kind of evidence. I think it was always based on kind of this vague feeling that it was dangerous to have too much of a calorie deficit. But if you look at the evidence, I don't see what danger there is. Like, it's not like people are dying. It's not like people are having heart attacks. They're getting healthier and they're losing weight and they're maintaining it better. So to me, I think that's kind of certainly counter to the popular narrative around weight loss.
Interesting. Yeah, I have not heard that. I'll definitely have to look at that study that you mentioned then. And you said you tweeted that out recently?
Yeah, I just tweeted that out today. Today is November 4th.
Excellent. Excellent. Very good. Well, Dr. Guyenet, I really appreciate you spending the time with us. We will definitely stay in touch, and thanks for joining us today.
Okay, my pleasure. Thanks for having me.
Some outstanding insights from one of the leading researchers in the world in this area. For those of you who would like to keep track of his latest findings, recommendations, articles, etc., he's pretty active on Twitter. You can find him at WHSource, WHSOURCE, or feel free to connect with me. I'm at Catalyst, CATALYST, 2, Thrive, THRIVE, as I do my best to retweet highlights from, frankly, most of our guests. So that's an easy way to keep track of them. Thank you to all of you who have passed along the comments that you have about the podcast. If you'd like to help us out, and a lot of you have asked us about, hey, how can I help? I'm told it makes a big difference when you go on and make a 5-star rating on iTunes. And obviously, anytime you do a testimonial with your friends and you pass something along to them, that makes a huge difference. So if you've done either or both of those, thank you so much. If you're thinking about it, that'd be awesome. As always, please don't hesitate to reach out to us. Email is results@catalystcoachinginstitute.com. Anytime. If you have questions about that national board exam where everything's changing next year, if you'd like information about the big early registration discount for our retreat next year, that wraps up into December. So there'll still be some discounts available, but the big one is available through December 31st. Or if you have any other questions about health and wellness coaching, reach out to us. In the meantime, folks, let's go get better. Whatever better is for you today, let's go get it. Thanks again for joining us. This is Dr. Bradford Cooper signing off. Make it a great rest of your day, and I'll speak with you soon on the next episode of the Catalyst Health and Wellness Coaching Podcast.